All righty, good morning, lads and ladies. Welcome back to MAC 1140 section OR1. Today we are going to talk a little bit more about this kind of machine diagram interpretation of a function and what it means to run that thing backwards. Let's get the document camera switched on. Now, the other thing, you guys are my only pre-calc class that is not a Tuesday, Thursday. And I set the exam date for my Tuesday, Thursday classes. I'm not sure we have set our exam date yet, so we need to do that. I think, yeah, same here. They have their quizzes up, but you guys do not yet. Let's talk about the test for a minute. I think you guys are like exactly 1 day behind. So here we go. This, of course, and as always, is MAC1140. Section number is OR1 recap. Today is the 20th of September, 2021. Today we're going to talk about the test. I think we have finished 2.7, right? Yeah, you guys have also finished that. We don't need to go through that. But we do need to talk about 2.8. So exam 1, and then we're going to cover section 2.8 on inverse functions. I need to spend 1 second here to throw the animals outside. Sorry, things are very chaotic here this morning. All right, who's Wallace? Come on. Yes, you ate your breakfast. Come on. Come on. You got 2 choices. You want fish, you want the cat. You have to go. All right. You're gonna have to wait. So, exam 1. Section 2.8, this is the last section we have to cover for the test. Right? If you look on your syllabi, you will see that exam 1 covers from 1.1 through 2.8, which means that today we're going to be covering the last bit of material that will be on exam 1, right? So we are right here, and we're a little bit behind. That's not the end of the world. Today, I'm going to release for you a quiz in WebAssign that is going to cover kind of the material between the last quiz and section 2.8. And I'm also going to post to Canvas some scans from the textbook of the chapter tests as they are in the text and some reviews as they are in the text, just extra problems for you guys to work on if you're feeling a little bit uncomfortable. That way you have extra material to study. Now, my advice is certainly to make sure you do the homework first, right? Make sure you work through the homework problems until you're comfy with them. Make sure you solve the quiz problems, work them until you're comfortable with them. If there's one that you got wrong, especially if like after using all of the attempts on the quiz, you still weren't comfy with that problem, even if you got it correct, if you just kind of felt a little bit shaky about the process, those are things you should go back and review. You should bring to office hours. You should ask questions about with tutors. But if you've done all of that and you want a little bit more study material, I've had a few people say that they would like more. There will be something in Canvas going up today. It's just going to be scans from the textbook, some extra problems for you guys to work. It's not graded or anything like that. You don't have to do it if you don't want to do it. It's just there so people have more material to review for the test if they want it. So let's write some of this down. It's going to cover section 1.1 through 2.8. First things first here, let's discuss the date. So today we are going to finish the material for exam 1. We're going to finish section 2.8. And I'd like to give you a little bit of time to prepare. I think having the test on Wednesday, I'll let you guys decide. All right, let's do it like that. So there are two kind of reasonable choices for the test date. The first reasonable choice would be this Wednesday, which is 9/2. And the other reasonable choice would be next Monday. That's 9/7. Right, 9/27. Yeah, okay. Before I let you vote on this, I'd like to discuss with you a little bit some things you should think about. If we have the test this Wednesday, that will put us back on track schedule-wise. It will mean that there's going to be a little bit more time to prepare and cover the material that will be on the next test, right? This is a 4-exam class. We're going to have 4 midterms through the year, and then we're going to have the final at the end. This particular test, I would argue, is not the hardest in the class. And if you wanted to have more time to study for the later tests, taking this test on Wednesday would be a good way to help that happen, right? So if you feel comfortable, confident with the material that you've seen in the homework and quizzes so far, then taking the test this Wednesday would be a good idea, because it would free up a little bit of extra time for you to prepare for the next test. On the other hand, if you're feeling less comfortable with this material, and you know you would like that extra time to study, then you could vote to have the test next Monday. I'm fine with either. Personally, I don't have a strong opinion one way or the other, but I want you guys to make choices that are beneficial for you in the long run. So the next test after this is going to be in about 2-3 weeks, and it will cover polynomial and rational functions and their graphs. There's things like polynomial division, factoring, complex numbers, stuff like that, rational inequalities. That exam tends to be one of the tougher ones, and it comes pretty quick, you see, just a few weeks after the first test. So if we push this test back to next Monday, that would compromise the study time for the second test. That would mean that the second test is going to have to be delivered a few days after the last bit of material for that test. So it's up to you whether you'd like to do the test this Wednesday or next Monday. I'm going to go ahead and save the question, launch the poll. You guys can vote. Just remember to vote your own interests, right? If you think that having the test this Wednesday would not compromise you in an unpleasant way, then you should vote to do that. If you think that you really need that extra time to study, then you should vote to have the test next Monday. Another bit of information that may be relevant when you make this decision, so I'm not going to launch it just yet. The test can be taken one of 2 ways. You can take it online, and this would mean proctoring by HonorLock and Zoom on your phone. And I talked about this a little bit at the start of the term, but let me just remind you the way the Zoom proctoring thing works. If you're going to take the test online rather than at the testing center, then you will need to sign into Zoom on your phone. You'll need to set your phone up somewhere kind of off to the side near your desk where I can see your work surface, your hands, your lap, and the paper that you're going to be writing on. So I need to be able to see all those things that I would want to see if you were taking the test in a classroom, because HonorLock on its own is not sufficient proctoring. So if you're going to take the test online, you would sign into Zoom on your phone, set up your phone so I can see your desk, your hands, your lap, your paper. And then once you get the okay from me in Zoom, you can sign into the test and begin the HonorLock process. HonorLock will record your screen, your webcam, and Zoom will record all the other stuff that I would want to see. The other option is to take it at the testing center. Which is in Building N on the Northwest campus. Or if you're out of town, but you happen to be living in like a university town where they have a testing center that non-university students are able to go to and use, I would be fine with that. But these are the two options. You can either do it at a registered official testing center. I would recommend Santa Fe's, or you can do it online with the combination of HonorLock and Zoom. If those decisions impact your availability, then that's something else to take into account when you choose here. All right, I'm going to go ahead and launch the poll. It's like we still need 3-4 people. Okay, so next Monday is now ahead by an amount where even if the remaining 4 people all voted for this Wednesday, next Monday would still win. Okay, so your test is going to be next Monday. Which is 9/27. All right, here are the results. There we go. All right. So exam 1, next Monday, you have a choice. You can take it online, proctored by HonorLock and Zoom, or at the Teaching Center, Building N, Northwest Campus. If you're going to take it at the Teaching Center, you need to send me a Canvas message letting me know that's what you want to do, because I need to reserve you a spot at the testing center. With the number of hybrid and online classes that exist right now at Santa Fe, the testing center gets very, very busy. Do not expect to be able to just walk in there and take it on that day. You need to make the arrangements ahead of time. So you need to reach out to me, send me a Canvas message. I will then let the testing center know to expect you on that day. Regardless of where you're taking it, you'll need to be taking it during class time. Now I can stretch that window a little bit if you're taking it at the testing center. Like if you have another class right before this or another class right after this, so you can't get there and then get to wherever else you need to be. If you're going to take it at the testing center, then I'll give you a like hour window on either side of class. So you could start there. Well, I don't think they're open at 7, actually. Let me see. Yeah, 8 a.m. So you could take it anytime between 8 and let's say 15. You could start anytime between like 8 and 9 at the testing center. If you're going to take it online, then you have to take it during class time. You have to take it, starting at 8. Office hours are today at 1 p.m. Yep, that's correct. Yeah, last Friday I had a department meeting, but we will have normal office hours today. All right, any questions about the test? Besides what are the correct answers?
I have one.
Yeah.
How many questions would you exactly put on it? Like 30 or?
Let me show you the format of my exams. I think I appreciate you asking that. It's good to give you guys a look. Now, obviously, I can't show you our test, but here's an example test from my differential equations class over the summer. Your test will look similar to this. It'll have the same breakdown of questions, same number of questions. So your exam, regardless of where you take it, either here online with me or on campus in the testing center, it will be in Canvas. It'll be an assignment titled Exam 1, Take the Test Here. The assignment's already there in Canvas, but it's empty. And it's going to look like this. So you're going to have some true-false questions. Each one will be worth 4 points. You're going to have some multiple choice questions, each one worth 6 points. And you're going to have some free response questions, each one worth 10 points. The true, false, and multiple choice are very straightforward. You select the right answer, you get the points. The free response questions work like this. So you're gonna, you get to this problem. On your paper, you are going to write out your solution. Once you finish solving the problem, you'll type your final answer and just your final answer in this box. That final answer needs to match the work and final answer on your paper. As soon as you're done with the test, as soon as you submit the test here in Canvas, you're going to scan using your phone and a scanning app like Cam Scanner or Adobe Scan or the Notes app on iPhone. You're going to scan that written work and submit it to the assignment in Canvas titled Exam 1 Written Work. The 10 points for each of those problems are broken up, for each of those free response problems are broken up as follows, right? There's 2 points allocated for typing the correct answer in the box. The remaining 8 points are based on your work. So there's a lot of partial credit there. This is generally a good thing for you guys, but you need to make sure of a few things. First, you absolutely must type your final answer in that box. If you don't type the final answer there, and you just leave me with the written work, then I don't have any guarantee that that's the written work you did during the test. Maybe somebody else's work you scanned or some bullshit like that. I don't know. So make sure you type your final answer in the box for the free response questions. Don't forget to do that. If you don't do that, I can't give you any credit. Make sure you write your work, right? Make sure you actually show your steps as you solve those problems. Don't just type the answer, actually write out your work in a way that's legible and possible to follow. And make sure that the work is organized in a way where I can tell which work goes with which problem. I'll be a little more specific about how I want you to format things on the day of the test. The written work is worth 8 points, and that's going to be broken down according to a rubric. And the correct answer being provided in the box is going to be worth 2 points. And for obvious reasons, the answer you type in the box must match the answer that you arrive at on your written work. The written work you'll have to submit while you're still here in Zoom. So you can, when you finish the test, you'll be able to close on or lock, you submit the test in Canvas, but you need to keep Zoom open in your phone and scan that work and submit it. You can turn your camera off in Zoom or whatever, but I need you to be here and be in communication with me while you're doing that. If you take the test at the testing center, just remember to either have them scan the work and send it to you so you can submit it online, or take the time to scan and submit your work there. But regardless of where you take it, you need to scan and submit the written work for the free response problems to the appropriate assignment here in Canvas. Okay. And then let's see, did I answer that question thoroughly? So true, false, worth 4, multiple choice, worth 6, free response, worth 10. And the total number of questions, what is, I think it's like 16 with the system I'm using now. 14 total. So you'll have like, yeah, 4 true, false, and 1, 2, 3, 4 multiple choice. And then the remaining 5 will be free response. Or remaining 6, sorry, free response. Any other questions about the test? Let's see, what times are we allowed to take it? So yeah, we covered that. Wednesday's lecture, yeah, if it's not up, I'll get that up real soon. Sorry, so the end of last week was quite hectic. Yeah, we still need the lecture from the 15th. Something you can always do, if you come to one of these old announcements here and just follow this, because I have other MAC 1140 classes, if you go to my YouTube channel and you want to see other lectures, you'll see in my playlists other MAC 1140s that you could take a look at, stuff like that if you want. But yeah, I will upload last Wednesday's lecture right away after class today. All right, that's enough class time burnt on talking about stuff, unless there are other questions. Are there any other questions about the format of the exam or what you're required to do, anything like that? And then again, how to study, make sure you do the homework, make sure you solve the quiz problems. Take note of anything that gives you a hard time as you do that, and practice those a little bit more. If you feel like you want more practice beyond that, have a look in Canvas. I'll be posting probably to the modules some scans of like exam reviews that you can work.
Along with the exam reviews, are you going to open any homework so we can look at that or no?
Oh yeah. I mean, if you want an old homework set opened, as always, just submit an extension request in WebAssign, I'll pop it open. You should be able to go back and review old homeworks, even if they've already come due. But if for one reason or another you're unable to get into something that you want to play with, just submit an extension request in WebAssign, I'll grant it, and then you are free to go around and work those problems again if you like.
Okay, thank you.
Yeah, of course. Well, there is also a feature in WebAssign called the personal study plan. Look around in your WebAssign for that, because that does a reasonable job of putting together problem sets, like extra practice for you, based on the problems that you've gotten wrong the first time you tried. So if there's a problem you got wrong maybe 2 or 3 times before getting it right, then WebAssign will include a problem of that sort in your personal study plan. That's another really good way to study. So last time we talked about how to combine functions, right? If I have 2 functions, f and g, I can add them pointwise and I get the new function I call f plus g. I can multiply them pointwise and I get the new function called f times g. It turns out that that last sort of operation where you compose 2 functions, plugging one into another, is intimately related to another concept called an inverse function. Before we talk about that, I want to just kind of begin with this idea. And that's really this question. Given a function f, can we find another function which exactly undoes whatever f does? So in terms of machine diagrams, where we think of f as like a machine on an assembly line. We talked about this when we talked about the composite functions. The f machine takes in x's and spits out f of x's. What we would want to do is run the machine backwards. And in terms of mapping diagrams, that's where you've got your domain over here, got your range over here. You've got your inputs getting sent to your outputs. This is the mapping diagram for the function f. What we want to know is, can we turn the arrows around? Right, and specifically, when we turn the arrows around, do we get another function? Or is that new mapping diagram we get not a mapping diagram for a function? Does it maybe violate the definition of a function somehow? Before I get into the nuts and bolts here, I'd like to just give you a particular example in terms of the machine diagram to illustrate how this could be a challenge. The one I came up with most recently was maybe this machine exists at a recycling facility and they get in a lot of soda cans, right? Soda cans, beer cans, whatever. One of the procedures in recycling is going to be to burn all that paint off, right? You don't want the label and logo all of the paint and chemicals involved with that stuff in your recycled aluminum product. So somewhere in most recycling facilities is a machine that takes in a can that has a logo on it. It comes in saying Coke or Pepsi or whatever, and it burns off all the paint. So the blank aluminum can comes out. Is it possible to figure out which blank aluminum can had which logo on it? Is it possible to run this machine backwards and take that pile of blank cans that you have as the outputs, run the machine backwards, and get exactly the pile of painted cans you started with? So intuitively, I think most people want to answer this question with a yes. Yes, we can run the machine backwards. Sure, just run the belts the other way. Yes, we can turn this diagram around. Just point the arrows back the other way. But in the case of the machine here that burns off the paint logo, you have as your outputs a pile of blank cans. And if I want to run that machine backwards, I need to know which logo to paint on each can. How do I know which blank can was a Coke can, which blank can was a Pepsi, Sprite, or some kind of beer can? You don't. You don't. Because the machine F, the original function, destroys information somehow. It doesn't preserve the information which can had which logo. It sends all the different inputs, Coke, Pepsi, Sprite, whatever, to the same output, blank aluminum can. So the answer to this question, can we find another function which exactly undoes whatever the original does, is yes, but with some stipulations, only under certain conditions. Only if the original function somehow preserves the information. Looking at an output, which input did you come from? Looking at the blank can I tell what the logo used to be? No. So it would be hard for me to run that machine logo can, that can logo machine backwards the other way, right? That would be a real challenge because in my outputs, there's nothing to tell me which output came from which input. In terms of mapping diagrams, this problem can be illustrated quite literally. So consider the following mapping diagrams. I'm going to explicitly tell you the inputs and outputs. This is 1, this is 2, this is 3. And here I've got like 5, 11, and 13. If the function f sends 1 to 5, sends 2 to 11, and sends 3 to 13, if this is what the function f does, then the function that undoes f we get by reversing the arrows. So here, the function that undoes this, f sends 1 to 5. So the function that's going to undo f would have to send this 5 back to 1. F sends 2 to 11. So the function which would undo f should send 11 back to 2 and should send this 13 back to 3. This function is called f inverse. The inverse of f, and it's denoted by f inverse. Right, so f of 1 is 5, f of 2 is 11, f of 3 is 13. F inverse of 5 is 1, sends that 5 right back home. F inverse of 11 is 2, sends that 11 back to the input from which it came. And F inverse of 13 is 3. Here's another mapping diagram. This process, and I'll say, however, this process can be complicated, can be messed up. So here again, I'll just think of my domain as being the 3-element set 1, 2, 3. And in the range, let me just put the single element 5. And let's say F sends all of these guys, both 1, 2, and 3, all get mapped to the number 5. What happens if I try to turn these arrows around? So let me actually come back here. So in the original notation here, I would say F of 1 is 5. F of 2 is 11. And F of 3 is 13. Reminding you what this notation means. And the corresponding statements about the inverse would be that F inverse of 5 is 1. F inverse of 11 is 2. And F inverse of 13 is 3. All right, in that first diagram, where we didn't have any problems. In the second diagram, if I wanted to write this in function notations, we'd say F of 1 is 5. F of 2 is 5, because 2 also gets mapped to 5. And F of 3 is 5. All of these are equal to 5. So here's my question. What is F inverse of 5 in this second diagram?
Would it just be all 3?
Reasonable thing to think, right? Because we're saying that this inverse is what you get just by turning the arrows around, and that's correct. The inverse relation sends 5 back to 1, sends 5 back to 2, and also must send 5 back to 3. Is F inverse a function? So is the purple mapping diagram, whose input space only has 5 and sends 5 to both 1, 2, and 3, is the purple thing here a function?
No.
Good, no, it's not, right? Where that's after here, inverse of F denoted, D-E-N-O-T-E-D, meaning written as. Yeah, the purple thing here is not a function, right? And in fact, it would be wrong in a sense to say F inverse of 5 is 1, 2, and 3, because every function should send each input to one and only one output. Here, F inverse has only one input, 5, but it wants to send that one input back to both 1, 2, and 3. So F inverse here is not a function. So the challenge, remember what we said? We said we want to find, given a function f, we want to find another function that exactly undoes f. Here there is no function that exactly undoes f. The relation that exactly undoes f isn't a function. You can still undo f. It's just that the resulting thing which undoes f is not a function. And in calculus especially, we really like to focus our attention on studying functions. I want to know where you are on the graph when you just tell me the x value. Remember, we made this big deal when we talked about increasing and decreasing, how when I ask you where is something, you just give me the x value. That's the beauty of studying functions, that their behavior is entirely determined by the input. You tell me which input you're talking about, I know exactly what part of the graph you're discussing. So here, the purple arrows are not a mapping diagram of a function. And so we would be unhappy if we had to work with this. We don't like working with non-function relations whenever possible. So the question becomes, what sort of functions have inverses which are themselves functions? Right? What sort of restrictions do you need to put on the original function to guarantee that when you turn the arrows around, you get another function? An example of one is this guy, right? This guy didn't have any problems. Here, the purple arrows do describe a function, right? Each input for the inverse, which are outputs for the original, like 5, goes to one and only one output. Each input for the inverse goes to one and only one output. Unlike here, where one input for the inverse goes to 3 different outputs. So what is different about this first guy that makes his inverse nice, a function, than this guy, which makes his inverse not nice, not a function? Does anybody have a feel for what's going on here? Want to take a guess?
Each one gives a unique output.
Yeah, Shauna nailed it. The definition of a function says every input goes to one and only one output. But the word unique is very special. If every input goes to its own unique output, then every output must have come from a unique input. And that means you're talking about a one-to-one function. So the answer to this question, Shauna nailed it. Every input for the original, for F, must have its own unique output. The word for this is one-to-one. So if you look, for example, at this guy, the bad function here, the original function, f, the black arrows, send the input 1 to the output 5, sends the input 2 to the output 5, and sends the input 3 to the output 5. There are 3 different inputs going to the single output here. This is called a 3-to-1 function because each output gets hit by 3 different inputs. There are 3 inputs getting mapped to the one output 5, 3-to-1. This guy is called a 1-to-1 function. Every one input gets mapped to just one output, right? In other words, I said that wrong, but every input gets mapped to its own unique output. No output over here gets hit by multiple inputs. You see here, if you tell me the output, I can look at the diagram and say which input it came from. Here, if you tell me the output, I can't look at that and say which input it came from. You tell me, okay, I'm fucking around with the output 5. Which input got sent to the output 5? Was it 1? Yeah. Was it 2? Also, yeah. Was it 3? Oh shit, yes, that as well. So I cannot tell you what f inverse of 5 is, right? And still be talking about a function. I would have a multi-set here, or a set containing more than one element there. So the necessary condition for a function to have an inverse relation, which is also itself a function, is that the original function be 1-to-1, in the sense that every input for the original has its own unique output. And this is called being a 1-to-1 function. Okay. So let's take a look at the graphs of some 1-to-1 functions, the graphs of some non-1-to-1 functions, see how we can detect whether a function is or is not one-to-one from the graph. And then we'll look at how to find some inverses, because that procedure is one you need to know. And that's really going to be the big game here. I'll also give you a set of equivalent statements that are useful. TFAE. So graphs of one-to-one functions. One-to-one, I may abbreviate as 1-1, if that's okay with you, just so I don't have to write out the words. And non one-to-one functions. There's another word for one-to-one, by the way, you may see it in your textbook or other places, called injective. It's actually easier to look at this in the negative than in the positive. So here's an example of a function. Say this graph is y equals f of x. And if I just pick on a specific y value here, let me call this y value here 1. Notice that there's two x values, call this x1 and x2, that get sent to that same y value. So notice that f of x1 is equal to 1 and f of x2 is equal to 1. This means that the function I'm looking at here is not a one-to-one function, because the two different inputs, x1 and x2, maybe this is like 1/3 and this is like 3 or something, 1/5 and like, I don't know, 10, whatever. Two different inputs get sent to the same output. Two different inputs, specifically here, x1 and x2, get sent to the same output, in this case, the number 1. An example of a function which is one-to-one something like this. No matter what output you pick your favorite y value, there's only one point on the graph with that y value, which means there's only one input that gets sent to that particular output. So here, for each output, y value, there is at most one, but I'll just say only one input, x value, which gets mapped to that output. So geometrically, what is this saying? Geometrically, what this is saying is, if you draw a horizontal line anywhere in the plane of the second graph, it will hit that graph at most once. Whereas on the first graph, if you draw a horizontal line here, for example, it will hit the graph twice. The thing we've just illustrated is called the horizontal line test. So if some horizontal line hits your graph twice, that means that the y value of that horizontal line is associated with at least two different x values on your graph. And that would mean that your function sends those two different x values to that same y value, meaning your function is at least 2 to 1, maybe worse, definitely not 1 to 1. So this is a theorem, and it's called the horizontal line test. In brief, it says if any horizontal line hits your graph more than once, then that graph is not of a 1-to-1 function. And the converse here is, or not converse, but contrapositive here says if no horizontal line hits your graph more than once, then your graph is a 1-to-1 function. So what you want to do, if I give you a graph and I ask you, is this function 1-to-1? You want to imagine drawing a shitload of horizontal lines. If any of those horizontal lines touch the graph more than once, then the answer is no. Joyce asked an excellent question in chat. She says, so is it impossible for an even function to be 1-to-1? Yes, it is. It is impossible for an even function to be 1-to-1 because they always have y-axis symmetry. Just to be clear, this is not an even function, right? Because he's not symmetric about the y-axis. He has his own axis of symmetry over here. But yeah, any function that has an axis, whose graph has an axis of symmetry, which is a vertical line, automatically not 1-to-1. And that includes even functions. It is indeed impossible for an even function to be 1-to-1. So the horizontal line test, something you may have seen in previous algebra classes. If not, here it is. A function is 1-to-1 if and only if no horizontal line touches the graph more than once. The way we usually think of it is if any horizontal line touches your graph more than once, then that function is not 1-to-1. I don't think you guys need practice with this beyond this, right? Just look at the graph, imagine a bunch of horizontal lines. If any line hits that thing more than once, not 1-to-1. What I would like to get us practice with is finding inverses. All right, so I have a 1-to-1 function f, and I would like to find its inverse. The procedure is this. First, write y for f of x. All right, so if you've got like f of x equals blah, 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 just swap out that f of x for a y, the thing that you were doing in middle school. Second, solve for x. And I know that this is probably different than what you've seen before, right? A bunch of people say, you know, swap x and y first, then solve for y. Don't do that. Promise me you won't do that. First, write y for f of x, then solve for x. Because now you're going to need to consider possible domain issues. You see, sometimes we like to invert functions that aren't 1-to-1. And the way you do that is by restricting their domain. For example, this guy you see over here, you can still see him through the paper, right? If I threw away this half, if I were to throw away this half of the function and just keep this stuff, that is 1-to-1. And sometimes what we do when we want to invert a function which is not one-to-one is precisely that. We just throw away part of the graph and say, I'm not going to worry about that. I'm just going to invert this piece. This is why you want to swap x and y later. Because if you change the labels x and y, you'll have a hard time figuring out how your domain restrictions overlap with the algebra. I'll show you what I mean. So consider it domain issues, then swap x and y. And you're done. Now, y is f inverse of x. Okay. So I'm going to run through this procedure with you a few times just to make sure you're comfy with it, even if you've seen it before. This is probably a little bit different than what you've seen. And then I will go into this whole domain issue thing and show you precisely why you want to wait to swap x and y and what it is I mean by consider domain issues. But for our first example, we're gonna take a function that is one-to-one. We're not gonna have to worry about domain stuff, okay? Here we go. Let's find f inverse of x, where f of x is x over x minus 2. This is a one-to-one function. I can show you its graph. Apply the horizontal line test just to be sure. Here she is. And then we can slide in. Try doing this, no, delete the AX, yeah. All right, so check out this blue line. Nowhere does it touch the graph more than once. It might look like you're gonna get into trouble here, but look, it doesn't. It jumps from the right to the left and never does it touch the graph more than once. So we're good. This is indeed a one-to-one function. So my first step is to write y in place of f of x. My second step is to solve this equation for x. How would I do that? Anybody have an idea how we could begin solving this equation for the variable x? Okay, maybe I'll get us started.
Would we substitute for like what do we change y to 0 or something like that?
No, I just want to solve this for x. So I'm going to leave y as y. I'm going to leave x as x. I'm not going to plug anything in. I just want to do whatever algebra is necessary to get x alone. And it is a little bit tricky here, right? Because I've got an x up here and I've got an x down here with this thing. So let me tell you the secret. The secret is cross multiply, get rid of all the denominators, and then pull every term which has an x to one side and every term which doesn't have an x to the other side. So if I cross multiply, I get y times parentheses x minus 2 is equal to x. Multiplied both sides by x minus 2. Then I'll distribute that y. So I'll have yx minus 2y is equal to x. And if I gave you this, I bet everybody would be able to tell me how to solve this for x. What would be a good next step here? I see there's something in the chat. So
You
I've
just
got-
divide everything by x.
Not quite, because then I would have all of this over x. But if I subtract this guy over to the left and I add this guy over to the right, so I'll have yx minus x equals 2y. I've added this to both sides and I've subtracted this from both sides in here. Now I can factor an x out on the left. We'll have x times y minus 1 equals 2y. Now I can get x alone just by dividing both sides by y minus 1. This is a procedure you will have to recreate at least once, probably more than once. So let me, y minus 1. Let me remind you kind of the strategy here. We cross multiply to get rid of all denominators, distribute everything, then pull every term that has an x to the left-hand side, and every term that does not have an x goes to the right-hand side. So this guy had an x, he needs to come over. This guy didn't have an x, he needs to go away. Now that every term on the left-hand side has an x, I can factor x out. And what's left won't have an x. And then I just divide over by this stuff that doesn't have an x, and I've got x alone. So it's a sneaky procedure. I'll tell you, I'm not shy about this. On my very first pre-calculus test myself, MAC1140.0R1 way back in the, I'll tell you how long ago. I was given something like this and I panicked. I shit myself and I didn't know what to do. I was like, how do you do it? It's impossible. Ah! But no, it's not impossible. It's not at all impossible. This is how it's done. So that's step 2 done. We've solved for x. Step 3. There are no domain issues here. F was 1-to-1. Now you might notice that the domain of the original is all numbers except 2. The domain of the inverse is going to be all numbers except 1. That's fine. But there was no domain restriction. The original function was 1-to-1. So now we're ready to swap x and y. So I take this statement and I rewrite it as y equals 2x over x minus 1. And now y is f inverse. My last step here is just to rewrite this as f inverse of x equals 2x over x minus 1. That's it. That's it. We have found our inverse. First, questions on this procedure? Any questions on the steps there, what we did, why we did it, how it worked? Okay. So I claim that this function right here exactly undoes the original function. How would we test that claim? Question, can we check our work? Well, if I have a function that I believe exactly undoes some other function, that means that these two guys should behave a particular way with respect to the composition operator, the last operator from the previous section, 2.7 on combining functions. If I start with my bare feet and I put on my socks and shoes, consider that a function, right? Function takes in bare feet, puts on socks and shoes. The function which exactly undoes that would be take off shoe, take off sock. right? In that order, right? You got to take the shoe off first, then the sock. If I were to do those two things consecutively, put on sock, put on shoe, that's the original function, and then take off shoe, take off sock, that's the inverse function, I'm going to get out a bare foot, which is the same thing that I started with. If you start with x, do f to that, then do f inverse to that, you should get x back out. Whatever f did to x, f inverse should undo. So here is a fact, and the answer to this question. In fact, some people take this as the definition of the inverse function, your textbook included. Let's see. The inverse, f inverse, to the one-to-one function f is the function, by definition, must satisfy the following. F inverse of f of x is equal to x. And if you run it the other way, f of f inverse of x is equal to x. In the other notation, this could be read as f inverse of f of x equals x, like this, or f of f inverse of x is equal to x, like this. Right, so if you start with x, you do f to that, and then you do f inverse to that whole thing, you should get back what you started with, x. So in other words, if you want to check whether or not you have two functions which are inverses, we compose them. If the result is x when composed both ways, then the functions are inverses. So let's take the one that we just had. I'll say verify that f inverse, the thing that we think is the inverse to that function, which was 2x over x minus 1, really is the inverse of f of x equals x over x minus 2. Okay, so how would we verify that? Well, I need to compose. I need to verify these statements for these particular functions. So we'll begin by computing f inverse of f of x. If this comes out to x, then we're on the right track. If this doesn't come out to x, then these can't possibly be inverses of each other. Remember, this by definition is f inverse of f of x, like this. That's what the composite symbol means, that circ symbol. which is f inverse of, what is f of x? It's x over x minus 2. So in other words, to check if two functions are inverses, you plug one into the other and see if the result simplifies to x. Now, this function is also a fraction. So we're going to be plugging this fraction into this function, which is itself a fraction. You need to be very careful with your algebra. We talked about this a lot last week. If I'm going to plug something in here, that means I'm going to replace these x's in parentheses with this expression. So that's 2 times parentheses x over x minus 2 divided by x over x minus 2 minus 1. Take a quick pause here and make sure everybody's comfy with what this is saying. Are there any questions about how we arrive at this expression? Okay, then are there any suggestions as to how I can begin simplifying this expression?
Would we cancel out the x over x minus 2 or no?
Well, is x over x minus 2 a factor of the bottom? Or an equivalent question, can I cancel the x's in this? All right, remember we've just plugged in here. Oh, sorry, let me do this right. Yeah, sorry. Can I cancel the x's in this? This is the one we're asking about. No, because x is not a factor of the bottom, right? Here, I've got x over x minus 2 minus 1. This expression is not a factor of the bottom, so I cannot cancel it. Remember, you can only cancel top to bottom common factors. So if you're wondering, can I cancel this? You should ask yourself, can I factor that? So if we want to cancel x over x minus 2, we would have to factor x over x minus 2 from the bottom. And since this 1 right here does not have a x over x minus 2 that I can factor out, we can't cancel. Reasonable thought, right? Good question. But the answer happens to be no. So instead, what could we do to start trying to simplify this? We've seen stuff like this in the homework, right? As early as the first one. You need to have a common denominator down here, right? I've got 2 terms in the denominator. One of them is a fraction, the other one is not. If I'm going to simplify this big fraction, I need to have the bottom written as a single fraction. So the first thing we should do here is have a common denominator downstairs. The top I'll leave alone, 2 times x over x minus 2. Downstairs, I have x over x minus 2 minus 1, which I'll write as x minus 2 over x minus 2. And now the 2 pieces downstairs have the same denominator. I'm going to continue this. The top is going to stay this, 2 times x over x minus 2. Now downstairs, I'm allowed to subtract those fractions because they have the same denominator. So this is x minus x minus 2. And remember, the tops and bottoms of fractions are always in parentheses. So this is x minus 2 in parentheses divided by x minus 2. Now I would write it like this. So we have that common denominator downstairs. Now I will distribute this negative to these 2 terms, combine like terms, flip and multiply. I have 2 times x over x minus 2. That's my big numerator. My big denominator is x minus x, which is 0, plus 2. So that's 2 over x minus 2. Questions so far? Okay. Then I will flip and multiply by the bottom. So the top stays the same. This thing which I'm dividing by, we flip and multiply. It's x minus 2 over 2. Now, if I write this as a single fraction, I've got 2 times x minus 2 upstairs. That's this 2, this x, and this x minus 2. Downstairs, I've got this x minus 2 and this 2. So now we can do some cancellation. The 2's cancel. The x minus 2's cancel. And we just get x, which is what we wanted, right? That's what we needed to verify. We compose the functions. We should just get x if they are inverses. We do just get x, so they are inverses. Now, technically, if I wanted to verify that this really is the inverse of this, I should also compose in the other order, right? We need both of these things to be true. I'm going to leave it as an exercise for you to compose in the other direction. Algebra steps like these, like this simplification, you will absolutely have to do on the test. All right, we've had lots and lots of stuff like this in the homework. I know it's something that a lot of us are kind of allergic to. We don't like messing with complicated fractions, but this is one of those things that we need to get comfy with in this class. So I'll pause here again for just a second in case anybody wants to ask a question about any one of these steps. Okay. All right, then. Before I let you go, I want to share with you a theorem, and we're going to talk about this a little bit more next time. Theorems like this are a lot of fun. This is a theorem on characterizing inverses. And it says the following are equivalent. TFAE, the following are equivalent. 1. F of A is equal to B is equivalent to saying 2, the point A comma B is on the graph of F. Which is equivalent to saying F inverse of B is equal to A. All right, I think it's pretty clear that these two are equivalent. And I think it's pretty clear that these two are equivalent. It's not super obvious that these two are equivalent, but they are through that chain. This is equivalent to this, which is equivalent to this. And then all of these are equivalent to saying the point B comma A, right? Look, F inverse takes in the input B and sends out the output A. Point B comma A is on the graph of F inverse. And I want you to pay careful attention to items 2 and 4. AB is on the graph of F, means BA is on the graph of F inverse. I'll leave you here with a little note. Items 2 and 4 above imply a certain symmetry between the graphs of F and F inverse. And I'll get specific about that symmetry and talk about how to invert after restricting a domain next time on Wednesday. So we're going to look a little bit deeper at this on Wednesday. I'll show you how to invert a function that's not one-to-one. Like we said earlier, you're just going to throw away part of the domain. And then I'll show you how to get the graph of the inverse function from the graph of the original function and vice versa, even if you don't know algebraically what the inverses are. All right, that's what I have for you guys today. I am going to go ahead and pop open this quiz for you in WebAssign. You're going to have a quiz 2, which is on 2.6 through 2.8. Think of that as part of the material to help you prepare for the test. Also, take a look in Canvas. I will be posting some scans of review material that you're allowed to work if you'd like, but you're not required to work. It's not for a grade. It's just to help you if you want more study stuff. What else? I think that's it, gang. I think that's it. I'm going to go ahead and post your 2.8 homework. There's a little bit more to 2.8 that we haven't covered yet. I want to look at examples of this stuff and also examples where you have to restrict the domain, but please do go ahead and get started on that today. If you need help with anything, you can come by office hours. I do have an office hour this afternoon from 1 to 2 p.m. You can post a Discord, send me a Canvas message, all the normal stuff. That's it. If you want to take the test in the testing center, send me a Canvas message so I can reserve a spot for you. Otherwise, I will assume you're going to take the test with us online, which requires signing into Zoom on your phone simultaneously being on HonorLock and whatnot in your computer. So please make sure you've got your technology shit ready. Make sure that you have an environment where you can take the test, either testing center or somewhere quiet at home or wherever. And if you need to talk to me about anything, please reach out as soon as possible. We can get stuff resolved sooner rather than later. It'll be good. All right, that's it for me for now, guys. I'll see y'all on Wednesday.